All right, this is part 3 of lesson 3.9. We're looking at example 3. So here we're going to have two car rental services. This service A charges $50 for a daily fee and 20 cents per mile. Service B charges a daily fee of $40 and 30 cents per mile driven. So this value is going to be your start value. And since this is per miles driven, that is going to be your rate of change. And this is going to be your start value here of $40, and the 30 cents per mile is going to be your rate of change. And one of the nice things, when you have a rate of change, they give you the units, your units are in your rate of change. Your dollars is going to be your Y value, the total cost in dollars. Total cost in dollars, right? Don't like the way that A came out. There we go, that's better. And then the X value is going to be miles, number of miles. And so for our equations, very similar type of build as we did on the previous two. This is your rate of change, so this is going to be 0.20. You can put 0.20 if you want, X, and then your start value is the $50. Here, Y equals 30 cents, right? That's your rate of change, 30 cents per mile, times the number of miles, plus $40. So those are our two equations. Now when I come over here, remember these are miles, this is dollars, miles and dollars. 0 miles, we're going to put 1, 2, 3, 4, 5, and same thing here, 0, 1, 2, 3, 4, 5. And now when we look at that, our start value is 50 for this one, and we're going to add 20 cents. So 1 mile is $50.20. If you drove 2 miles, it would cost $50.40. And we just keep adding plus 20, plus 0.20, right, to each side as this increases by 1. So this will be 60, 80, and then $51 even. Now let's go to the other table. Here in service B, the start value is $40, and now we're increasing by 30 cents each mile, right? So this is going to be plus 30 cents every time we increase a mile. So this would be $40.60, $40.90, $40.90, $41.20, and $41.50. Now looking at these, are any of the rows identical in the tables? No. Right? This goes from 50 to 51. This goes from 40 to 41.5. We don't have any rows here. Now we could continue to extend this table, but we have no idea if the equal values will even show up here and how long that's going to take. Using the table is not an effective method. If we tried to graph it, well, we don't know how big our scale needs to be. So in this case, I am not going to go directly to the graph. I want to find out where do these two lines meet, and the table isn't showing it to me right away. And I don't really have enough information to decide what scale to put on my graph. So what we're going to do here is we're going to jump to the solving algebraically. This is called the equal values method. Once again, we write the two equations down. Y equals 0.20x plus 50. And our other equation was y equals 0.30x plus 40. Those are our two equations. And what we're saying is, if these y's are equal values, in other words, this is when the cost is the same for both companies, how many miles do you need to drive, x is the number of miles, for the cost to be the same? So equal values means I'm assuming these are going to be equal at some point. 0.2x plus 50, 0.3x plus 40, these should be equal for a certain x value. So I'm going to set them equal together. Equal to each other. Once again, I'm going to put the x with the bigger number in front on the left side and the x with the smaller number in front on the right side. And just like we did with the other ones, flipping. So we flip all the x's over to the left side. So this flips to a negative 0.20x, and the 40 flips to a negative 40 on the right. Then we go ahead and simplify. This is 10. Over here, we simplify. This is 0.1, or 0.10 if you'd like. So there we go. That is our flipping and combining. Last step, dividing. What do we divide by? It's always by whatever is in front of x. So since there's a 0.10 in front of x, we will divide by that to both sides. This is what I call a calculator moment. Just put that in your calculator. 10 divided by 0.10 is 100. And that tells us that the cost is going to be the same at 100 miles for each company. Now, let's verify that. And how much is that cost? So if x equals 100, let's take the first equation. Y equals 0.20, and in place of x, I put 100 plus 50. 0.20 times 100 is 20. Verify that on your calculator. And then 20 plus 50 is 70. So for company A, or service A, it costs it costs $70 if you drive 100 miles. Well, what about the second company? It should be the same. So 30 cents times 100 miles plus $40. Well, 0.30 times 100 is 30. And that's 40. And if you add those together, you get 70. So both companies cost $70 if you drive 100 miles. Now that I know where the intersection is, the intersection is at 100,70. Now I have a good idea of what scale to use on my graph. So let's flip back. So for this graph here, remember x-axis, this is going to be, x was miles, and the y-axis was money, right, total money. I'm just going to put those down for our values. And if we're going to 70 and to 100, I could probably go by 5s on this one. And I'll make this 5, 10, 15, 20. Now I'm only marking every 10s, right? So 10s, 20s, 30s, just to make it a little quicker. 50, 60, 70, 80, 90, 100, 110, 120. So those are my miles. Remember, it's at 100 miles that the intersection occurs. Then for the vertical, I'm going to go by 5s as well. So 5, 10, but I'm only going to mark every other one. 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now remember, our two equations are y equals 0.20x plus 50 and y equals 0.30x plus 40. So 40 and 50 are my y-intercepts. So I'll put a dot at 50 and a dot at 40. I know that the cost is the same at 170. So if I go 100 up and I go 70 across, that puts me right there. I think that's pretty good. I can verify that, and I do recommend, especially when you get to your project, verify that's 100. That looks good. And then just double check across. That is at 70, so that looks good. So I don't really need to put in every single point here. These 2 points are good enough. I can use this one here and that one here for line or service B, right? Because that started at 40. Okay. Draw that line out, and that was for B. And then for this one, that's A. So bring my pencil in, my ruler in onto the pencil. Make sure I'm at a good spot there. Double check, make sure everything looks good. I'm pretty happy with that. That is line A. So remember, this is B over here, this is A over there. Sorry, I apologize. It was a little crooked, but it's a little easier to draw with the ruler that way. So all I did was connect these two lines with these 2 points with the ruler, and then these 2 points with the ruler. This is line A, this is line B. Now we know line A started out more expensive. It was 50, right? But it didn't increase as fast. It was only 20 cents a mile versus 30. So we can see it has a lower slope. This one started out a lower value, right, or lower cost. It was 40, but it increased quicker, so this has a steeper slope. This is where the two lines meet. After this, company B is actually more expensive than company A. So if you're going to drive under 100 miles, company B is cheaper. But after 100 miles, company B is more expensive. You want to go with company A. So that's the answer to the question. All right, you know what? I just realized I did this on the wrong sheet. Here's my work here, and I should have put that in this spot. Whoops. All right, well, hopefully you didn't make that mistake that I did, but let's continue on to the last problem. And this problem, how am I doing on time? 11 minutes. I'm going to stop this video here, and on part 4, you will see the last problem, the last example.